Hi, good day, everyone. Hi, good day, everyone. Can you confirm if you can hear me? Hi,
Yes,
guys. Can you hear?
I can hear you.
All right. So once again, good day, everyone. Welcome to the first live coding session for this cohort, and today we'll just be talking briefly on introduction to machine learning in Python, which is the stage course that you guys are currently going on in. So the live coding sessions happen weekly when you are divided into tracks. But for this stage A, we shall be having 4 live coding sessions actually. So because stage A encompasses everyone, and since everyone is going to be involved in this stage A, then we are going to have 4 coding sessions that is spread out over the next 2 weeks for this stage. So starting from stage B, then different people will have different times for which you have their coding session in a week. And by then, the live coding sessions will drop to 2 per stage. So two per track. Per track. So the DevOps track, they will have 2 live coding sessions. The data storytelling tech will have 2. The data science and the data engineering guys will all have their different tracks that they are going to be participating in. So the essence of the live coding session is to have like a practical demonstration of whatever it is we are doing in the internship for better learning, for us to be able to showcase what it is that you guys are doing in a practical sense, and to also give insights into it. So it is mostly a session that it lasts for 1 hour. In some cases, it might be an hour 15, depending on how long it takes for us to go through whatever it is we are going for the day. So without wasting much more of our time, being the introduction to Python for machine learning, and the stage just started yesterday, so some people have not even accessed their course yet. So today we'll just be taking 2 things. I hope we're able to finish the 2, but we are going to be going sequentially. So basically, the 4 live coding sessions will just try to introduce to us the popular libraries that we're going to be utilizing for Python. The popular libraries in Python that we're going to be using for machine learning, basically, since everyone is partaking in this stage. So when we get divided into our different tracks, then we'll be focusing more on tools that you guys will utilize in your different tracks for whatever it is that you are doing. Okay. So before I go on, can you guys confirm if you can see the screen that is being shared? Can someone just drop a chat to just confirm that you can see the screen being shared?
I can see the screen.
All right, thank you very much. So since we can see the screen being shared, let's go. So today we shall be using Google Colab. So you guys might use things called you can use your Jupyter notebook, you can use Anaconda. All of these are fine, they are perfectly fine. But Google Colab give us a way to not burden our system with some of this because it might be tasking to run some machine learning codes and all on our systems. So Google Colab give us a way to do this on the cloud. Google Colab gives us a way to do this on the cloud without tasking our system too much in that way. So this page here is Google Colab, and to access Google Colab, I don't know, just to access Google Colab, let me open a new tab and just click on Google Colab. When you go to Google and you look for Google Colab, so it's called Google Collaboratory, that's the full meaning. So as long as you have a Gmail account, you have access to Google Colab. It is free to use, and even as you are going on further, you can see that you can have access to called GPU. So this is welcome to collaboratory, blah, blah, blah. So if you just click on a new notebook here, a new notebook will be created for you. And everything you are doing is being stored on the cloud. So even if you have an issue where, let's say you have an issue where your data gets exhausted while you're coding or something, or at least all of the code that you have written is, at least all of the code that you have written is being stored on the cloud. So you have access to continue with this code anytime you want to again. So this is another instance of Google Colab. So that's all you have to do. Once you have enabled your Google Colab, all you have to do is to connect your Colab. Even if you don't connect, once you type any Python command, Google Colab only understands Python and some of Linux. That's the way Google Colab works. So you can use some Linux commands, and you can also use some Linux commands, and you can use, but every Python command or every Python code that you type into the Google Collaboratory can be understood by Google Colab. So all you just have to do is to click on this connect. So when you connect to me one time, you have the ability to start running Python code on Google Colab, and that's why you need to start coding Python. So it's a way for you to easily start working on projects without having to stress yourself about the hassles of if your computer can handle the workload or not. So if I come here now and just type print LCS, so this internship not only assumes, because that's why we also gave you guys the onboarding stage where you guys go through the prerequisite course. So we believe that you guys should have an idea of what Python is and how Python works, because it is not an easy thing to start teaching people to go about how not that it's not an easy thing. The focus of this internship is not to teach people how to use Python or how to code in Python. The focus of the internship is to use Python for machine learning, data science, and any other track that it falls into. So therefore, we will not be going into the nitty-gritties of explaining how to use Python or what a Python command is, or probably explaining for loop, while loops, and stuff like that. So because we assume, and not only assume, we also provided that platform by giving you guys these prerequisite courses for you to have acquainted yourself with all of this. So this is me saying LCS. So as you can see, LCS has been printed on the screen. So the first, once you go through your stage courses also, all of these that I'm saying are things that you will see also. The first attendance form, this is not a webinar. So for webinars is where we give an attendance form, and the attendance form for webinars are very, very important. The attendance form for webinars are very, very important. The attendance form for webinars are very important. So when that time comes where we'll be having attendances and stuff like that, we'll let you know. But the live coding sessions are not mandated to have attendance. There can be cases where the live coding sessions will have attendance to be filled, and we'll let you know beforehand if there will be an attendance to be filled. But for today, there will be no attendance form for this live coding session. And over time, if there will be an attendance to be filled, we'll let you guys know beforehand. So as I was saying, the first stuff we'll be going through today is the Numpy library. So I'm going to do an import Numpy. So when I import Numpy, so now Numpy is a library. So the usual standard in data science and machine learning is to use abbreviation when you are using a Numpy. So as I've said again, as I'm seeing on the chat screen, you do not need an attendance form for today's session. So there will be no attendance form for today's session. Thank you. So as I was saying, when you import Numpy, the standard in machine learning and data science is to use the NP abbreviation when you are importing Numpy. So I can do something like import Numpy as NP. So after importing Numpy as NP, then we have the standard of to use Numpy. So the essence of using Numpy is it gives us a way to it gives us a better way to work on arrays and numbers, because normally we could have used lists and stuff for all of this stuff, but Numpy is a library that has provided us a way to perform matrix operations very easily. So Numpy is a library that helps us perform matrix operations, and it does it in a parallel processing kind of way where operations are performed very, very fast. So things in Numpy are called the Numpy array, and the first thing we are going to be doing is we'll create something called the Numpy array. So to create a Numpy array, use np.array 1, 2, 3, 4, and I'm going to run this, and you can see that this has been created as a what? As a Numpy array. So if this has been created as a Numpy array, then you can begin to perform what? Numpy array operations on this. So to see in Numpy, we have things called dimension, just like in matrix also. So we have things called dimension of arrays. Dimension of arrays just tell us how the number of rows and the number of columns in the array. So rather than just talking, let me say that. So the first thing we have is called a zero dimension array. And to showcase that, let me do this. I'm just going to put in a number. Let me say number 42. So once I press enter, so I've created an array that I've stored into A. So now I'm going to print A. So after printing A, you can see A is 42. If I do A.shape, you can see that there is nothing written here. So when you have a zero dimension array, when you check the shape, there will be what? Zero. There will be no value. There will be no value because the array is a zero dimension array. That means it contains a scalar. A zero dimension array is basically you saying that this is a what? This is a scalar. So moving on from zero dimension array, we have what? One dimension array. So one dimension array is what we created earlier here, where I put a list of values inside a list. So this here is called a one dimension array. And if I run this and check the shape of this now, you see that now we have what? The number of things called here. There's a number here. And what is this number? 4. So what this 4 is saying is that what? We have 4 items in this one dimensional array. So when you have a one dimensional array, when you check the shape, when you check the shape of the one dimensional array, you have just a single value in the 1D array, and that value shows you the number of things that you have in that 1D array. Yes, this video is being streamed live on YouTube as we are speaking currently, and it is also being recorded. So if you want access to this video after this session, once you go to our YouTube channel, that's amoye.com on YouTube, you'll be able to find this particular video, because there are people that are joining this session that are also on YouTube that are not joining through Zoom. So once you, even after the session, you can go to YouTube and you'll still find the video there. Is that okay? And as I've said previously, Sean Joseph, for today's session, there will be no attendance, being the first session in the course. So continuing with what I was saying earlier, so when we say A.shape, you can see now that we have this value called 4. We can see that we have this value called 4, and we have this value called 4, and 4 denotes the number of things we have in the item. So if I come here and include another number, let me say number 5, and then I run this code and check the shape, you can see that the shape has increased from what? It has increased from 4 to 5. So that is a one-dimensional array. So moving on from a one-dimensional array, we also have things called two-dimensional arrays. So the way two-dimensional array works is that we have what? We have more than one dimensional array, basically, the way it works. So to showcase what a two-dimensional array is, I'll just come here. So one thing you should notice is that anything you are creating in a Numpy has to have an outer list that is being defined in. So if I come here now, for example, and just do something like this, and just create another array, let me go from 6 to 7 to 8 to 9. This give me an error, because what everything that we are defining should be encompassed in a what? In a list. So it can be what? A tuple, it can be a list, it can be anything. But anything we are defining, as long as we are defining an array, you have to what? Encompass it in a list on its own. So if I highlight all of this in here and put it in a list on its own to show that everything is being defined as an array, and I run this will now work successfully. You can see now that this has run successfully and creating from a ragged nested sequence. So this is just a warning error that is trying to complain about the way in which we are creating the sequence, which is a list or a list of of different lengths is duplicated. So this is just a warning that now you should have the same number of things, because Numpy works in a way that it tries to make performing numerical operations very fast. So to perform numerical operations very fast, there are ways in which your data should be structured that will make it what? Easy. So this error now, if I want to, based on what I've read here, and this is probably because this is a new update to Numpy. Using previous versions of Numpy might not have given you this error. So I have 1, 2, 3, 4, 5 items here. If I increase this also and add the number 10, I should not see this error here. So that error was trying to tell me that in Numpy, you are advised to have what? When you are creating an n-dimensional array, you are advised that each and every what should be the same thing. You see why that is now. If I come here and write shape, and I run this code here to check the shape as a 2D array, you see that we will not have one value here. Now we will have two values. So these two values is now showing that we have what? 2D array, and this 2D array has 5 values in each of them. That is basically what we're trying to say. So this is the first 1D array here, and this is also the what? The second 1D array. This is a 2D array. So from 2, you can go upward, you can go to what? Any number. So all I just have to do to increase the number of arrays here is to just add another what? List that contains 5 elements. If I just go 11, 12, 13, 14, and 15, and I run this code here, it will change to what? 5. This 5 means that we have a what? 3-dimensional array, 3D array, and this 3D array has 5 elements in what? In each of the array. So it's basically saying that this is a what? Basically saying that this is a what? Something that has 3 rows and 5 columns. And if I come here and print out this array, if I print out A and run this code, you see that it is showing you in the matrix format. This matrix format is showing you what? It's showing you this as a what? Something that has what? A first row, a second row, a third row, and how many columns? 1, 2, 3, 4, 5 columns. So that's the kind of arrays that we can have. The kind of arrays that we can have in Numpy. So you are not limited to 2, 3, or 5. You can have a plethora of arrays as long as it is what? Within. You can even have nested arrays that will be more than what? That will be more than 2D. These arrays here are still what? They are still 2D in nature. You can have arrays that will have what? Even as long as 4 numbers or 5 numbers when you are what? When you are typing in the shape. These arrays are called what? They are called higher dimensional what? Arrays. So to create something like this, if I come here, for example, this array here, if I come to this array here, okay, so I need to take away this now and specify that the number of dimensions NDIM should be 5. Okay, it has to be number of dimensions. So if I run this as expected, that code has run successfully. So after taking the number of dimensions, if I put this out now, you see that this has been nested. If I print out the shape, shape, and we see the shape here, you see that the shape is what? The shape has 5 values in there. 1, 2, 3, 4, 5 values. This is how you specify higher dimensional arrays. So you need to have an idea of what value, the kind of array you want, and how you want your matrix to be structured. So when you know that, you can create the kind of arrays that you want. Okay, so let me I don't want this. Let me delete this here and just go back to when we had a 2D array that had what 3 columns. So let me put this out now. So yes, we have rows and 5 columns. So there's something called indexing, accessing the elements of an array. It's just like accessing the element of a list. So indexing should not be a new word because you access element of a list just as you would access element of array. So the syntax to access elements in a NumPy array is basically the same thing. So if I come here, this is the name of the array. I name the array A. So if I want to access the first element, we start our indexing in Python from 0. So if I click on enter now, you can see that I've accessed the first row in this array. For more context, let me come here and print out the array here. So you can see that when I say A0, that's getting the first index of the array here. You can see that we have A0, which is what? 1, 2, 3, 4, 5, which is the first. So if I go to 1, you can see that we have the what? This is the second row. If I go to 2, and enter, this is the third row. But if I go to 3, there will be an error. Why is there an error? Because in Python, we start our indexing from what? For indexing, we start our index from 0. So we go from 0, 1 to 2. An array that has 3 rows can only be indexed up to 2. You get the first row with index 0, get the second row with index 1, and the third row with index 2. You cannot use this. It will give us an error. If I do 2, I'll get what? Array 2. So you can have multi-indexing. What do you mean by multi-indexing? So you might not just want to get everything in row 1. You might want to get in row 1, you also want to get the third element or the fourth element in row 1. So after specifying 0 here, you just provide a comma and say that, okay, I want the first element in that same row 1. You can see that this value have returned 1, which is this here. If I change this comma and change this comma to the value of 2, you can see that it will give me 3, which is what? In the first row, the third element. An alternative way you can do this is to use double brackets. Instead of using a comma now, if I provide 0 in this other index, this is also 1. If I also come here and provide 2 here, this is also what? 3. So this is showing you that you can have a multi-indexing, a multi-access, where you can access each and every element of array. Any array is accessible. Because in this full array, this first row here is an array on its own. This is also an array on its own. This is an array on its own. So all of them are what? Accessible. So that's what accessing the element is. So even if you have a 2D array, if it is a 3D array, all you just have is to what? Provide the appropriate number of what? Boxes or the appropriate number of commas, and you'll be able to access the elements in that array. Another thing that we have is also slicing. Slicing is also the same thing as when we slicing is basically the same thing as in list also. So if I want to slice the first array to just give me the first 3 elements, and I do this, you can see that I have array 1, 2, 3. So all of these are list methods. They are basically list methods that are what? That are just we use here just to have an idea of whatever it is you're working with. So in an array, you can have different type of data types. But one thing about Numpy is that your data type should be what? Your data types should be the same, because it will not be nice for you to have different data types in the same Numpy array, because pandas, when we get to pandas, you see that we can do something like that. But in Numpy, it is not really accepted to have multiple data types in the same array. So if I come here and say a.d type, so I come here and print out the data type. D type corresponds to data type. So you can see that this is what an integer array. If I come back to A, when I was creating it, after creating this, I say that D type is equals to specify S. This is for string. If I do this has run successfully. If I print out the shape, it will still be the same thing. But now if I print out A, you should expect to see that instead of having numbers here, the values will be having are what? Are strings. You can see that you have this is a string of 1, a string of 2. If I come here and print the data type of A, you can see that we have a data type of what? S2. So this is a 2-dimensional array of strings. Basically, that's what this data type is saying. And the way Numpy works is that Numpy works by raw text or binary text. That's why it has appended something called B to all of this. If I do a print here and run this, so this B that is being shown here shows that it is what? A binary text, because even though it is working on string, Numpy is what? Numpy was made for calculation of numbers. So it has to have a way for it to be able to manage when you give it a string type of data type. Not only strings and numbers can be, you can also give it a float value. You can give them an undefined integer. You can specify the particular type of integer that you want. So if you guys read more on this, as you see in your stage also, we have different type of integer. There's integer 32, there's integer 64, there's integer, there are even higher integers also that you can use when you are working on Numpy. So you can also reshape a Numpy. You can also reshape a NumPy array. So when you go through the documentation of NumPy, you see that it's possible for you to reshape an array from one shape to another. But there are rules that have to be followed when you are reshaping an array, because reshaping an array, the array that you are going to shape into must be what? Must be feasible. What do we mean by that? So if I come here, let's check this. If I come here and say, hey, let me just create a new array called B. So this new array called B, mp.array. So let me just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I created this new array called B, and it has 12 things there. So if I check b.shape, I'm seeing just one thing. As you can see, we have just 12 items, and this is a 1D array. So I can do something called C. Let me say I want to create C, and I want C to be an array that has 4 rows and 3 columns. What do? I'll say b.reshape. If I do b.reshape, and I specify that in b.reshape, give me 4 rows and 3 columns. If I do this, if I print out C now, you see that our first.
Sorry to interrupt, but we cannot see the point of the screen where you are writing the code.
You can see this point of the screen.
We can see. We can see
now.
Okay, now you can see it. All right. Apologies for that. So as I was saying, you can see that I created an array B. After creating this array called B, it had 12 things, and on taking the shape of B, you see that B is a 1D array that has just 12 things in it. That's the B. So to create a new array called C, I called the reshape function, and I reshaped our first array, which was B. I reshaped it to what? To have a new shape that is what? 4 rows and 3 columns. This is a 2D array with 4 rows and 3 columns. And after running this, you can see that out C is now an array that has what? 4 rows and 3 columns. If I check the shape of C, this will have 4 rows and 3 columns. So the reason why this is possible is because 12 items is actually divisible into 4 by 3. Imagine I'm trying to do something like 5 by 3 now. This will give an error because you cannot reshape an array of what? 12 into 5 by 3. So there are constraints that you have to follow when you are trying to reshape an array. If you are reshaping an array and that constraint is not being met, there will be an issue. So you will not be able to use that. So another way that I could reshape this into 2 and 6. I could reshape this into 2 and 6. And if I run this, you see that now, if I come here and put the shape of C, C has been reshaped into 2 and 6. If I clean all of this and enter this, you can see that now we have 2 rows and 6 stuff. So this is just showing you that for you to reshape something, the constraint, and the constraint has to do with the new shape and the previous shape. So when all of this is easy to calculate, because logically you can see that we are trying to reshape 12. So probably the shape you are multiplying together must be able to give you the new shape. That's logical. That's something we can do now, as this is a very, very small array. But when you start getting to larger arrays, it will become a little bit more complex for you to be able to calculate all of those shapes. But you should know that it's possible to reshape two arrays, different arrays, into what? Into one. So just to give you guys a sense of what 3D array is, because I don't think I created something like that. I can reshape this into a what? Into a 3D array. If I reshape this into a 3D array, so this will have what? Two rows, three columns, and each of those will have what? Two items. Let's see how that will look like. So if I run this now, okay, and print out this C, so you can see how this is now. So this is basically two rows. That's the first thing. That's the two rows. You can see that we have those like two items here. After having two items, each of them has what? One, two, three. This is another what? One, two, three. So you can abstract this to say that, okay, after the first two rows, which is the outer number of rows, you have what? The second one specifies the number of rows that each inner array will have. So you can see that each inner array has what? One row, two row, three row. The third one also has one row, two row, three rows. And then the last number will signify what? The number of columns that each of them will have. You can see now that this has two columns, this two columns. So if I just try to even change this a bit and go to 3, this will also not work because this array cannot be broadcasted. So you need things that can what? When you are able to manipulate those numbers together, I'll give you 12. What's another way that we can manipulate numbers together to give us 12? We can have something like 3 times 4 times 1. This also gives us 12. So if I run this now, this should work as expected. And if I come here, basically what I'm going to have now is I'm going to have 3 items, and each of those 3 items will have 4 rows, and each of those 4 rows will have just one item in them. So if I run this row now, you can see this, just as we have said. This is the first item, the second item, and the third item there underneath. And each of them has how many rows? 1, 2, 3, 4, 1, 2, 3, 4, and each of them have one item in them. So you need to understand the constraint that happens when you are trying to, the constraint that is attached to you trying to like reshape an array for you to know that you can do this. But it's very, very possible for you to do what? For you to reshape arrays. So another thing you can do is you can join two arrays together. You can search an array, but let's leave all of that. These are things that you can learn by yourself. So anytime I'm talking to people like this, I normally encourage people to learn how to read documentations, because there's nothing you want to do that has not been done before. And as long as it's possible for that library that you're trying to work with, you will see someone that has done it before, or you see a similar case scenario. You see a similar scenario that is able to tackle that issue that you have faced before. So you guys should learn how to work with documentation of libraries. You should learn how to be able to attune yourself to reading documentations and knowing what those documents much. I'll say you guys should be able to attune yourself and understand how to go through documentations of code. So when you're able to use all of this, it will be easier for you to work on new things. So you can go and read the documentation of Numpy for you to gain more of that stuff. So another thing we are going to talk about is the numpy.random function. So just as we have random normally in Python, we also have a random that was used by Numpy. So the guys that created Numpy, when they were creating Numpy, they created a dedicated random function for Numpy. And to use that, you just have to use the words. You just have to use the np.random. So to use np.random, you just have to use np.random. You will be able to do this. You'll be able to call all of the functions that what the NumPy has in the random stuff. So if I want to, just like we have in the normal way, if I want to specify a random integer, so all I just is np.random.randint. So once I say 100, this should give me a random number that is what? Between 0 and 100. If I run this now, so you can see random number 47. Once I run this again, we have another random number. If I run this again, another random number. You can have a constraint that, okay, I don't want any number that is lesser than 80. Once I put this constraint, I will not have any number that is what? Lesser than 80. That's getting a random integer. So to get a random floating point number, and you guys work with floating point number a lot, you just use random.rand. When you use random.rand and run it, you don't have to specify a value. It gives you a random float number that is between 0 and 1. So that's 0 point something, any random floating point number. Floating point number are decimal numbers. So it gives you a random decimal number that is between 0 and 1. That is when you are using that's how to generate a random stuff. So you can also generate random array. If you want to generate a random array, you can just give it the size. So to generate a random array, if I say np.random.rand integer, out of the random integer, sorry, I forgot the int that is meant to be here. So .rand is 100. Okay. Now I'm going to specify something called size, and I'll give me size 5. So once I do this now, you can see that an array of 5 random numbers have been returned. If I change this to 6, you can also see that I now have a new array that has 6 random integers. So you can also specify the size for a 2D array. To specify for a 2D array, all you just have to do is, instead of providing one number here, you have to provide 2 numbers. So if I want number of 3 by 4, you can see now that a random array with 3 by 4 shape has been produced. So even no matter what size, even if I want this to have 1, it will give me anything I specify. If I say this should be 5, it will give you the number, the kind of shape that I have specified. It will generate a random number for you. But when you are generating a random floating number, so that's when you want to use this. Let me just copy this here and come here to this. So you know that when we do this without specifying a number, it gives us just one value. But when you specify a value under it, let's say 5, for example, you see that it's giving 5 floating point numbers. If I specify not just 5, if you want a 2D array, in this point, you don't need a comma. Or you just need you don't need a tuple, sorry, you don't need brackets, just like in the last one. What I mean by tuple, you see that when we're specifying the size, we have to provide it in a bracket. We do not just say size equals to 3, 4, 5. So we have to provide the size in a bracket. But when you are working with random floating number, you don't need to provide brackets. You can just say I want 3, 4, 5, and to give you this shape of all having floating point number between 0 and 1. So you can also do things called random choice, where you select a random stuff. You can select random from a distribution or from an array. You just select a random number. When you want to introduce randomity, you don't want your app to be predictable. That's when you use the numpy.random. So there's also something, this one is very, very used. It's called, you can do binomial or normal distribution. So if I do random.binomial, because in data science, guys, you guys will be working a lot with something called distribution. So you need to understand the distribution of data, how the data distributes, and if it's a normal distribution, if it is skewed, if it is not skewed, even guys in the data science. Want to have a normal distribution, binomial distribution, for example, I'll just say n is equal to 10, it is equal to 0.5. That's probability, and the size is equal to 3. So you can see the random binomial. This has to be an issue with the way I'm spelling it. Okay, there should be no I here. All right, so run. I see that what this is me saying that, okay, out of 10 things, I want you to give me a binomial distribution that has probability of 5. So probability of 0.5, and the number of things. If I change this size to 1 now, I will have just one value here. Just one was selected. So is what is making us have 10 values. So if I want to say that, for a turn, for example, say I just want the n. So we have a probability of 5 of selecting 0, 1, or 2. So if I just run this here and run this, you can see that some places one is selected, in another place one is selected, 0 is selected, 1 is selected. So we have, in a way, we have just what we have done, a random binomial distribution for a point toss for 10 data points. So this is we causing a turn for head or tails and the probability of picking the head or the tail or something like that. So this is like, let's say, okay, the coin is not really appropriate because we have 0, 1, and 2. So let's say something like a die of 3 sides or a die of 6 sides. So this is how you can just like generate binomial distribution, which you can store something for anytime it is want to do it. So visualize how this is a normal distribution of something. We actually do when we start visualization, because in first stage also we should also do something about visualization. That is not properly done. We showcase how a binomial distribution showcases and how a normal distribution. So to use a normal distribution, that is np.normal, a np.random dot normal, and I just specify as usual. Okay, normal distribution, all I have to do now is to say, you can see that even Anaconda, the way it works is giving me, this is where you can see it draws a random sample from a normal distribution, probability, blah, blah, blah. It's even explain what all the parameters are. So you can see the location, the float or array like of floats. So when you provide a location means the what? The mean of the distribution. The mean of the distribution. The scale is the standard deviation of the distribution, and the size is the number that you want. So I want a normal distribution where the mean will be 2 and the standard deviation will be something around 4. And I want it to give me size. I want it to give me 2 data points in that normal distribution. Once I want this, you can see that these are the values. And surely if I calculate the mean of this distribution, that's the average, that's addition of everything divided by the number, this should give us 2. Okay, just to show that if I come here and generate this, so you can see that we also have something you can calculate the mean of array. Numpy gives you functions to calculate mean, to calculate product, and all of these things that you do in statistics. So Numpy gives you all of those statistics function that you can use. You can even do logs and stuff like that. So just to confirm that I'm getting the syntax, let me use something like 1, 2. So I do this. So you can see that the mean of 1 and 2 is 1.5. So if I take this away, so I'm just trying to do this so that you can next, if you don't want your code to be unnecessarily long, you can next numerous arrays together. So Numpy can generate an array that will return an array that you will next in another function and stuff like that. So if I calculate the mean of the array that is generated by this function, you should have a value that is very, very close to 2. This is minus 1.2. That's the random stuff and stuff like that. But basically, this is how to generate a normal distribution in Python. And for each side, the normal distribution is located by being bell-shaped. So normal distribution is located by being bell-shaped. And when we get into visualization, I'll show you how to generate a kind of a distribution sheet for data points that will let you know what kind of distribution it is that you're working with. So that is actually like basically almost everything, because Numpy is actually a very, very exhaustive, is an exhaustive package that is being utilized for a lot of things in data science. So with Numpy you are given a lot of functionalities that you can work with. So with Numpy you can do something called matrix multiplication, where you can just you can have arrays of 30 by 30 and you just multiply each elements wise. There's something called element-wise addition and element-wise subtraction. Let me see if I can show something like that. Okay, so we have our array of A. Okay, we have not did that. Okay, let me use B. This B. Okay. So let me see the for C. So I want to show you that when you want to do element-wise, they have to be of the same shape. For example, now this is C. Let me reshape B to be something so B just reshape. let me come down on D. This is equal to B dot reshape. And I'm also going to give it comma 4, comma 1. Okay. So D has been reshaped. So now, if I do something times C, it will give me a value where each of the values in D and C have been reshaped. For example, you can see now, if I print out the value of D here, and if I also print out the value of C here, okay? So if I print out the value of C, control enter, you can see that here we have 1, 2, 3, 4. So D and C are basically the same thing, yes. You can see that when I do edit, it has just automatically done what? 1 times 1 is 1, 2 times 2 is 2, D is 16, 5 times 5 is 25, 6 times 6, blah, blah, blah. This has done automatically a what? An element-wise operation where everything has been what? Done automatically. But imagine if I try to do something like this. So let me reshape instead of D to be 4, 1 now. Let me make D 3 and 4. So now let me put D. This is 3 and 4. So if I try to do this operation now and try to run this should not work, you see, because it cannot be broadcast together. The shapes has to be in line for you to do something that is called an element-wise operation. But you can do something that is scalar multiplication, for example. So if I just say D times 2, you can see that every value in D has been multiplied by 2. So this is now 2, this is 4. So I give you a way to perform a lot of matrix operations that normally lists don't give you that. So because there's always this question of what are you doing with Numpy that lists cannot do? Is you can do all of this with lists, but with lists you have to start doing things like list comprehensions or for loops and stuff like that. And lists are not as efficient as Numpy when they are calculating operations, because the creators of Numpy did it for parallel operations and parallel processing. So calculating and performing large matrix operations with Numpy is very, very efficient and faster on Python. With Python now, because Python is always rumored to be a slow language, but the things like guys that created Numpy and co were able to do this stuff for them to be able to make all of this, for them to make Python what's easy for all of this stuff. So that's where we'll be ending today's live coding session, being the first one. So in our next coding session, the time and the date will be communicated to you guys. We'll be talking on pandas. So pandas is what we use basically in data science, because you have to understand NumPy to use pandas, because pandas was built on NumPy. So pandas gives you a way. What pandas does do, instead of you to see this array this way, pandas will make you be able to see it in a tabular form. It makes it more pretty. And pandas now introduce this function where you can now have numerous things together in the same array. So inside one array, you can have strings, you can have numbers, you can have floating points, and all of those kind of stuff in pandas. So pandas is what we'll be talking on in our next live coding session. So how to get the recorded presentation, as I've stated previously, once you go to our YouTube channel, amoye.com on YouTube, this session was streamed live on YouTube, and you guys will be able to watch this session. It was recorded live, and you guys will be able to see this session on YouTube. So you can refer to it anytime you need it. Okay, just as a one-time thing, as this is our first presentation, and a lot of guys on Slack are asking questions and stuff like that. So just to round up, if there's anyone that has a question or something, and the ones that are answerable to me, I'll try to answer them. Just give you guys some context. I'm trying to implore you guys to please always refer to your handbook. There are a lot of questions that you guys ask on Slack that we have spoken about in your handbook or in the welcoming mail that we sent to you guys. But due to the fact that you guys have not gone through your handbook extensively, that is why you keep having to ask all of these questions. So we are imploring you guys to please go through your handbook, go through the onboarding mail. You'll see a lot of these questions have been answered, and you won't have to stress yourself looking for these answers. Okay, I'm on the chat now, and I don't think I can see anyone that is asking a question or anything. So the script to this file cannot be, is because it's just something that was done on the air. So, but what I'll do is I can give you guys probably links, because when you go through everything I've said here, is inside your stage A course. So if you go through your materials, you see all of this and you have access to all of this code. So it's not something that you should bother yourself about. When you go to your stage A course, just go to your stage A course. Your stage A lasts for 2 weeks. You have enough time to go through these materials and answer your quiz. And when you do that, you'll be able to see all of this. So Elizabeth, I saying you are new to data science. Welcome to data science. I assure you that it's going to be a nice experience, but you have to be willing to learn. So if you don't know anything about Python, you have to go through our prerequisite course where we went through Python. So try to go to the prerequisite course where you learn Python, because if you understand Python, even if you have not worked with a library before, when you see a code, you should be able to get what that code is trying to say. So please go through Python, ensure that you understand the basics of Python, and then go through your stage A courses. You also see that everything that I've said today are also embedded in your stage A courses. If you have not been able to access the stage A course, please ask other guys, because I'm sure a lot of people have accessed the course, and people that have not accessed the course are only people that probably when they are trying to enroll themselves before, or they have not confirmed their email. So I don't know, some people are saying they have issues confirming their mail. They are looking into that. But a lot of people have accessed the course, and if you have been invited and you have confirmed your mail, you should be able to accept your ticket invitation. If you don't know how to accept your ticket invitation, you can go through a mail that was sent to you guys sometime around this time last week. We sent a mail to you guys for you guys to know how to accept your ticket invitation. So when you accept your ticket invitation, you'll be able to access your course. All right, so I think that is all for today. So as usual, you can reach out to us on help@amoye.io. Okay, already you have a question. Can you please, that will be the last question for this session.
So I have a question. It's about this .reshape. I saw where it was used one time, but I've been struggling to understand what the result was about, like the output. It's .reshape, open brackets, -1, 1, close bracket.
Yeah, so what that does is reshape -1, close brackets tells you that the -1 means it can be any number of value, and the 1 means that it must have 1 column. So what you're trying to do is that you are reshaping any data set that you have. It is mostly used for 1D arrays. So you don't, because everything I've done in this highlight coding session, you can see that I knew before and the shape that I want. But you might be in a situation where after you perform the operation, you might not know the number of things that you have. So -1 tells Python that, okay, I'm giving you the opportunity to determine the number of rows, but 1 means that it must be confined to 1 column. The inverse is you doing 1, -1. If you do 1, -1, 1 means that, okay, this the result of this array should have just 1 row, but I don't know the number of columns it can have. You have the ability to determine that, but I know that it must have just 1 row. That is what that code is doing.
Thank you very much.
All right, you're welcome. So with that, once again, welcome to stage A of the internship. You guys should go through your courses, and you can reach out to us anytime through the Ask Amoye channel, or through help@amoye.io, where we'll be able to attend to all of your questions. So you guys have a wonderful rest of the day, and we'll meet. The time and date for the next session will be communicated to you guys on Slack. Have a wonderful day. Thank you.